Hi, I'm Nicholas Belanger, and I'm going to be going over techniques for marking Brahminy blind snakes. A frequent problem associated with Brahminy blind snake research is the difficulty with estimating population size. Prendergast from 2017 indicates that individuals cannot be differentiated by appearance or genetically due to their parthenogenetic life history, which means that all individuals are genetically identical. Troes from 2022 says that small size makes marking them for capture-mark-recapture difficult using traditional means. Finding an effective way to mark individuals for recapture will advance population size determination for this species. So this presentation will be an analysis of various marking techniques in order to find a more reliable way to mark this species for CMR studies. The first technique being considered are scale clippings. Scales can be clipped by using a pair of sharp scissors and designating a code to identify the individual based on which scales were removed. According to Lang, using ventral clippings, these allow for more than 900 unique combinations. Some pros of this method are that it's cheap, it can be done in the field, and according to Brown, does not result in significant differences in behavior. Some cons are that the scales can regenerate with no visual differences, according to Conant, can be difficult to differentiate due to small size, and requires extreme precision to mark small snakes, according to Wynn. Lang states that this technique frequently draws blood, which increases the possibility of infection, and has been noted to affect the survivability of juvenile snakes. Another proposed technique is branding, which can be differentiated between freeze and heat branding. Both techniques are very similar. Either liquid nitrogen or heat is applied to a wire and, according to Lang, then pressed to the animal. Wynn proposed a more novel approach to heat branding that uses medical cautery units, which are compact and portable. The pros of this technique, according to Lang, are that they can provide highly variable markings. According to Wynn, medical cautery units are more portable and can be used to mark small snakes. Brands can also last up to 2 years. Some cons, according to Trost, are that this has only been successful with snakes 0.75 grams and larger, which only captures the largest Brahminy blind snakes. According to Wynn, it may require heavy and difficult to access equipment, and according to Lang, may cause injury and death in snakes, and the mark is not visible until after molting. A third proposed technique are pit tags, also known as passive integrated transponder tags. Pit tags are small electronic microchips that are inserted into an animal's skin via a needle or incision. Each tag fits a unique individual and is activated when the animal is scanned with a reader, displaying a code unique to that tag. According to Gibbons, pit tags have historically been used to provide a variety of information, including population size and density, but can also be extended to growth rate and the change in location of individuals. According to Wynn, some pros of this technique are that they have nearly 100% efficacy when implanted properly. They also are internal and cannot be removed when shedding or by physical abrasion. According to Keck, pit tags have not been noted to negatively affect growth rate or speed in neonatal snakes. Some cons of this technique, according to Wynn, are that they are relatively expensive, and according to Trost, the lightest pit tags are only functional for the largest blind snakes. The last technique I will be reviewing are VIE tags, which are known as visual implant elastomer tags. These tags are made of a liquid elastomer and is mixed with a curing agent and injected subcutaneously with an insulin syringe. The mixture hardens and becomes semi-flexible after a few hours and may be visible to the naked eye. If not, it is visible under the skin with the UV light, according to Trost from 2022. Some pros of this technique, according to Trost, are that no mortality has been measured when using this technique. The tags are light enough to be used with even the lightest blind snakes and can last up to 10 weeks. The color combinations associated with this technique allow the unique identification of hundreds of individuals. Some cons are that you may need a UV light to see the tag, and a lab setting may be necessary for implant. According to Major, marks may stretch and be confused with each other, and materials are slightly more expensive than pit tags. This is a more detailed look at VIE, with tags under UV light from 0 weeks to 10 weeks. Considering all of the techniques I have gone over, I would suggest VIE, or visual implant elastomer tags, in order to solve this problem. There are a few reasons why I would suggest this over the other techniques. It is light enough to use on all blind snakes and has not been noted to affect survivability. It is also capable for use in long-term studies and allows for many different combinations that allow for identification of a variety of individuals. This is particularly helpful considering that blind snakes do not have any visual characteristics that would differentiate them. This slide has a list of all of the resources I used when researching for this project. If you have any questions about Brahminy blind snakes or any of the techniques that I listed in this project, please let me know in the comments. Thanks for watching.